Section 7.6, Graphing Functions of the Form ax squared plus bx plus c. An equation written in the form f of x equals ax squared plus bx plus c, where a is not equal to 0, is called a quadratic. A quadratic equation. So let's take pretty much the simplest quadratic equation, y equals x squared. And let's think about what that graph looks like. Using just some values of x, some arbitrary values of x, we'll try letting x be 0. If x is 0 and y is x squared, what is y? Y is also 0. If x is 1, y is 1 squared, 1. If x is 2, y is 2 squared, 4. If x is 3, y is 3 squared, 9. So we have 0, 0. We have 1, 1. We have 2, 4. And we have 3, 9. So it looks like the line is going up, it's curved. What's happening to the left? If x is negative 1, you have negative 1 squared. That's also 1. So negative 1, 1. If you put negative 2 into the equation, you have negative 2 squared, which is positive 4. Negative 2, 4. Look what's happening. Whatever it was doing on the right, it seems to be doing a reflection on the left. This graph seems to be symmetric about the y-axis. You can fold it in half at the y-axis, and if you held it up to the light, you would only see one line. The y-axis is an axis of symmetry because it's symmetric to the right and to the left. This graph is called a parabola. It opens upward. The vertex is the point 0, 0. It's the origin. The vertex, in this case, is the lowest point of the graph because the parabola opens upward. The axis of symmetry is the y-axis, and the equation for the y-axis is x equals 0. All vertical lines are of the form x equals some value, and x in this case equals 0. So the graph of an equation of the form f of x equals ax squared plus bx plus c is called a parabola. A parabola has the following characteristics. The graph is U-shaped, orienting upward if a is greater than 0. If a is positive, it opens upward. It opens downward if a is negative. The highest or lowest point of a parabola is called the vertex, which is also the turning point of the parabola. It may be going down and it turns and goes up. It may be going up and it will turn and go down. The graph has an axis of symmetry, which is a vertical line that passes through the vertex. The curve goes on indefinitely. So to find the vertex and the equation of the axis of symmetry, what we want to do is we want to set x equal to negative b over 2a. Does that value look familiar to you? Negative b over 2a? Remember the quadratic formula? It's negative b plus or minus the square root of b squared minus 4ac all over 2a. And look at that negative b over 2a. It's this over this. It's the first part of the quadratic formula. So that's where the vertex is. We will find that the axis of symmetry is the straight line x equals negative b over 2a, and the vertex is the point where x is negative b over 2a. And what is y? I don't know. We have to solve for it. We have to evaluate the function at negative b over 2a to find the y value. So if we knew where the vertex was, if we knew where the axis of symmetry was, that would help us a lot in graphing the equation of our parabola. So let's begin this problem graphing y equals negative 6, or negative x squared plus 6x. Let's begin by figuring out where the axis of symmetry and the vertex is. So we have a is negative 1, b is 6, and c is 0. There's no number out there. So x equals negative b over 2 times a. That is a positive 3. So our axis of symmetry is the vertical line x equals negative 3. The axis of symmetry. So let's draw a vertical line at x equals 3. Let's make it dashed so we know it's not a part of the graph. It's an axis of symmetry. So our vertex is the point where x is 3. So we need to put 3 into our equation to find out what y is. So it'll be negative 3 squared plus 6 times 3. That's negative 9 plus 18 is 9. So 3, 9 is our vertex. Now we know that if a is positive, the parabola opens upward. If a is negative, look at it this time, a is negative, that means the parabola opens downward. So our parabola will be pointed downward or opening up downward. I would like some more points for this parabola. I think I'll use the number 4. That seems easy. So then we substitute 4 into our equation. Negative 4 squared plus 6 times 4. Negative 16 plus 24. Negative 16 plus 24 is 8. So we have 4, 8. Now using our axis of symmetry, we also have positive 2, 8. I want to go a little further. I want to find out what's happening at 5. Or you know what? Let's go back to 1. 1's easy. So that gives us y is negative 1 squared plus 6 times 1. That's negative 1 plus 6 is 5. So the point 1, 5 is on our parabola. And using our axis of symmetry, we know that the point 5, 5 is also on the parabola. All right, I think I know what it looks like now, but let me do one more thing. Because it's so easy, I want to put the point 0. Let's find out what y is when x is 0. So we get y equals negative 0 squared plus 6 times 0. That's 0. So we have a point here. It's 3 units away from the axis of symmetry. We go 3 units on the other side. And that gives us lots of points. So I think I feel comfortable now graphing my parabola. He opens downward. His vertex is the point 3, 9. That is the vertex. Let's clearly label that on our graph. Our axis of symmetry x equals 3. And that's it. That's our parabola. I'd like to point out a couple of other things. Look at these points. You have 2 points here, this one and this one. That's where the parabola crosses the x-axis. These points are x-intercepts. Then I'm also interested in the fact that this point is also the origin, 0, 0. That's also where it crosses the y-axis. So that's a y-intercept. It's an x-intercept and it's a y-intercept. So those are some other points we might be interested in. Let's graph another parabola. We have f of x equals x squared plus 8x plus 15. So let's find the vertex. We have a equals 1, b equals 8, c equals 15. So our vertex is the point x equals negative b over 2a, so it's negative 8 over 2 times 1, negative 4. So our axis of symmetry is the line x equals negative 4. Let's put that in our graph. Our vertex is the point negative 4. What is y? Well, we need to find out. Let's put negative 4 into our equation. We want f of negative 4. So that gives us negative 4 squared plus 8 times negative 4 plus 15. Negative 4 squared is 16 minus 32 is negative 16 plus 15 is negative 1. Negative 4, negative 1 is our vertex. Does this parabola point up or down? We look at the value of a. A is 1, it is positive, so this parabola points upward. Let's make a table and find out some other values so that we can decide what our parabola looks like when graphed. So what was our equation again? We had f of x, or y, equals x squared plus 8x plus 15. So we know that if it's negative 4, it's negative 1. Let's try negative 3. Negative 3 squared is 9 minus 24 plus 15. That's 24 minus 24 gives us 0. So we have a 0 to the left and to the right of the axis of symmetry. Let's do one more point. Let's put negative 2 into our equation. So negative 2 squared is 4 minus 16 plus 15. That's negative 12 plus 15 gives us 3. Using our axis of symmetry, there we have it. Find the x-intercepts of these equations. Now, it doesn't tell us to graph it. We don't have to graph it. We have to find the x-intercepts. Let's go back up and look at this graph and think about these x-intercepts. we know that we found two x-intercepts here. -5, 0, and -3, 0. Those are our x-intercepts. The thing that they have in common is that y is 0. What is x? Well, it's either -5 or -3. So to find the x-intercept, what we do is we set y equal to 0. Once we set y equal to 0, we need to solve this. It's a quadratic. How can we solve it? Can we factor? We can factor. Set each individual factor equal to 0, and you get two solutions, -2 or 1. Now remember, an x-intercept is a point. It's a point where y is 0. So one x-intercept would be the point -2, 0, and the other x-intercept would be the point 1, 0. Two x-intercepts. Let's solve this to find the x-intercepts. 0 is 2x squared plus 4x plus 1. Can we factor it? I don't think so. Let's try the quadratic formula. A equals 2, B equals 4, C equals 1. So x equals -4 plus or minus the square root of b squared minus 4ac all over 2a. -4 plus or minus the square root of 4 squared is 16 minus 8, the square root of 8 over 4. All right, that's the exact answer, but I don't really find it all that useful. I'd like to use my calculator to find what that is, a decimal approximation, because if I need to graph that, I will need a decimal approximation. I'm not going to have much luck graphing -4 plus or minus the square root of 8 over 4. So if we take -4 plus the square root of 8, and we divide that by 4, we will get approximately -0.293. -0.293. Suppose we take -4 minus the square root of 8. I am having trouble doing this. For -4 minus the square root of 8. And divide that by 4. -1.707. So that gives us two x-intercepts. The first one is -0.293. The second one is -1.7070. That's it. We have two x-intercepts. So let's look at our final example here and think about what the x-intercepts are. Can you factor this? No. But we can use the quadratic formula A is 1, B is 4, C is 5. So the quadratic formula tells us that x is negative 4 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Negative 4 plus or minus the square root. 4 squared is 16 minus 20, negative 4. Can we take the square root of negative 4? That's not a real number. There are no real X-intercepts. Let's see what's going on here. Y equals x squared plus 4x plus 5. I want to think about what this graph looks like. Does this graph point upward or downward? It opens upward because A is positive. What is the vertex? The vertex is negative b over 2a, so it's negative 4 over 2 times 1, it's negative 2. So it's the point negative 2, and what is y? Well, it's the quantity negative 2 squared plus 4 times negative 2 plus 5. That's 4 minus 8 plus 5, positive 1. This graph has an axis of symmetry at negative 2. It has a vertex at negative 2, 1, and it points upward. We're trying to figure out what the x-intercepts are, but if the vertex is above the x-axis and it opens upward, there are no real x-intercepts. There's just not one. So we've seen examples where there are two x-intercepts. We've seen an example now where there is not an x-intercept at all. Can you think of a problem or a graph where there would be just one x-intercept? A parabola where there's just one x-intercept. Or perhaps a parabola where there is just one x-intercept. Those are two possible parabolas that have one and only one x-intercept. Last example. The CEO of a company that makes lawnmowers was able to determine the profit for his company was P equals negative 2.2 x squared plus 396x minus 400, where x is the number of lawnmowers produced. What is the company's profit if they produce 50 lawnmowers? So if x is 50, we want to know what the profit is. It'll be negative 2.2 times 50 squared plus 396 times 50 minus 400. Can we put that in our calculators? Negative 2.2 times 50 squared plus 396 times 50 minus 400. $13,900. $13,900. How many lawnmowers should they produce to have a profit of near $10,000. Doesn't seem like it's going to be exact, but we want it to be nearly $10,000. So we have 10,000 is our profit. How many lawnmowers should we produce and sell? What is X? We need to solve this quadratic. In order to do that, what we'll do is we need to get equals 0. I'm going to jump down to the bottom here. So I'm going to subtract $10,000 from both sides. That'll be minus 10,400. We're going to solve this using the quadratic. These are large numbers. Let's go through and solve this. So we have the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c. All over 2 times a. Let's use our calculators. Negative 396 Well, I think first what I'll do is I'll take 396. I'll calculate the discriminant first, the part under the square root. So 396 squared minus 4 times negative 2.2 times negative 10,400. That's 65,296. So it's negative 396 plus or minus the square root of 65,296. The square root of that is approximately 255.531. All over 2a, which is negative 4.4. So we have...
Hey, all my